Hi everyone. In the previous lesson we looked at solutions to quadratic equations. So we were solving for x in a quadratic equation, or sometimes solving for things like time that would represent our x in a particular quadratic equation. We also found that those solutions were called zeros, which is a term we're already familiar with, or roots, sometimes called roots. So today we're going to look more into the nature of roots. We're going to learn more about different types of situations we could have where we might have two solutions, one solution, or zero solutions. So let's jump in. First of all, we see that we can have some different situations with a quadratic. We could have a quadratic that crosses the x-axis. We get our zeros here and here twice. So we could have two solutions, two zeros, two roots. We could also have a quadratic where just the vertex touches the x-axis. So we've got one zero, one solution, one root. We could, of course, also have one where, look at our x-axis, it never touches it. We could have a quadratic that's above and going up, or below and going down. In both of those situations, we would have no zeros, no roots, no solutions to our quadratic equation. And of course, when we're dealing with a quadratic that relates to an actual physical situation, those things would have meaning to them, and we're going to see some of those today. So let's get ready to jump in and learn more about this. All right, so a few important things here. If we have a quadratic relation and it doesn't have any roots, that means it can't be solved. There's no way to solve that quadratic equation. When we try and solve it, we get something called an imaginary number, which is what happens when you try and take the square root of a negative number. Go ahead into your calculator right now and try and take the square root of a negative number. Say -1, square root of -1, and see what your calculator says. Your calculator is going to have some problems with it. It's going to say it can't do it. So we could have a quadratic relation that has no zeros, no roots. It can't be solved. If we've got a single root, that means our vertex and our zeros are the same thing. If it has two roots, there are two solutions, both of which can be possible, but one of them may be inadmissible. Now, what do I mean by inadmissible? Well, here's an example. Let's say we had a person who is standing on a building and they're throwing a rock, and that rock is going to go up and then back down. Now, this, of course, is a quadratic. And you'd say, okay, with this quadratic, they're throwing the rock from here, so this is where they're starting, and it's ending up down here. If we made our axis something like this, right, our x and our y-axis, or our distance and our height axis, you might say one of our zeros is right here, and we get that solution. Where's the other zero, though? Well, it turns out the other zero is actually back here. It's right here. And so you would actually get a solution that is negative. Now, if you have an equation where you're dealing with time, like many of these thrown or like thrown rock or rocket equations have to deal with that, you could get a negative time. And what that would mean is it's something that was prior to the launch, and it doesn't actually have a physical meaning, right? Because in this case, you're not throwing the rock from the ground, you're throwing it from the top of a building. So in that case, one of these roots doesn't make any sense, and we'd get rid of it. And we'd only keep the one that does make sense. Okay, so you may have ones that are inadmissible, even if you've got two of them, when you consider the real life situation that it's attached to. Okay, so if we're going to determine the number of roots, there's actually kind of a nice little formula that's going to help us do it. First of all, though, if it's in factored form, this is what we focused on in our previous lesson. If it's in factored form, there's going to be two different zeros. Or there could just be a single one that happens to show up twice. So here are two situations, right? So the one on the left is just like what we looked at in our previous lesson. We'd say, okay, here are two possibilities for our zeros, for our solutions. We'd say one of them is at x minus 3 equals 0, so that means x is 3. That's one of them. Our other one is at x plus 5 equals 0, so that means x equals -5. That's our other one. So factored form is going to tell us there's two roots, so we'd say therefore two roots. What if we had a situation like this, though? This is a quadratic, and if we were to rewrite this quadratic, we could rewrite it like this. Since this is a squared term, we could actually write it twice. X plus 4 and x plus 4. Now, if we work that out, we end up having x is equal to negative 4, or x is equal to negative 4. It's the same one. So since it's the same one, we say the same 0 twice, and therefore 1 root. You could say there's 1 0, 1 root, 1 solution. There's only one, right? We just happen to see the same one twice, which is just telling us more emphatically that's the one. So there's only one. So these are the two situations when it's in factored form where you'd either have 2 or you'd have 1 that happens to show up twice. The other option, though, is we might have an equation that's in standard form. And if it's in standard form, it's a bit harder to tell. So if it's in standard form, we could have an equation that has 0 or 1 or 2 roots. We can use this thing called the discriminant. The discriminant is going to help us figure out the number of roots. So it's just a little formula. It's actually going to come into play in something later, but for now, the only part of the formula we need to know is this discriminant part right here. So in this, D stands for discriminant, and it's going to be b squared minus 4ac. So let's just remind ourselves, right? When you have it in standard form, a is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is just a regular number here at the end. So we're going to take our b, square it, and we're going to subtract 4 times a times c. That's our discriminant. Okay, we're going to do that calculation, and the answer we get is going to tell us something. If we get an answer that is positive, that means there's 2 roots, 2 solutions, 2 x-intercepts, 2 zeros. If we get an answer that's equal to 0, that means there's only 1. It only touches our x-axis at one spot. If we get an answer that's negative, that means there's no roots. That's our third situation, where it's above the x-axis going up or below the x-axis going down. There's no solutions, no roots, no zeros, no x-intercepts. So let's actually try this out. I'm going to show you the first one, then I'm going to ask you to pause the video and try the next two. Determine the number of real roots for the following functions. We say real roots because you can have imaginary roots. This is not something you'll see again till 12th grade math. It's again the square rooting of negative numbers. So I just want to mention that. You'll see that again. Okay, so our discriminant. We're going to take our b value. Our b value is negative 4. We're going to square it. We're going to subtract 4 times a, that's 2, times c, that's 6, right? A, B, and C. So we work that out. What do we get? We get negative 32 is our answer. So we say, okay, that's negative, therefore no roots, because it's negative. Okay, pause the video here, try the next two, see how you do. Okay, you're back. I'm going to go through these pretty quick. I'm going to say the discriminant for this one is negative b. B squared minus 4ac, so b is 6, minus 4 times negative 2 times negative 4.5. What does that work out to? That works out to 0. So we say, okay, therefore 1 root. How about our third one? B is 7, so 7 squared minus 4 times a times c. Well, it turns out c is 0. We're going to end up with just the 7 squared, so that's 49. Therefore, 2 roots. because it's positive. Now you could of course graph these on Desmos if you wanted to check. So let's do that. I'm going to hop over to Desmos now and I'll actually show you the graph of these three different ones. Here we go. Here's Desmos. So we'll say, okay, our first one is y equals 2x squared minus 4x plus 6. So we said that that one gave us a negative discriminant, and so it had no roots. You'll see that this doesn't cross the x-axis. It's up here above the x-axis. No x-intercepts, no roots, no solutions, no zeros. How about our next one? That one was y equals negative 2x squared plus 6x minus 4.5. You'll see that this one has just a single root right there. It happens to be our vertex. And that's the only way we can have a single root, only one spot where it hits the x-axis. Okay, how about our third one? That was y equals x squared plus 7x. Aha! Turn my other two off so you can see this one better. You'll notice we've got a quadratic here. It has two x-intercepts, two zeros, two roots, two solutions, where it hits the x-axis in two different spots. All right, let's keep on rolling through our lesson here. Here's an example. For this one, determine whether the vertex of the parabola y equals 5x squared minus 2x plus 4 lies above, below, or on the x-axis. Now I have no doubt that you could just go and graph this in Desmos, but we want to be able to really understand what's going on when we look at these. Okay, so first of all, let's just have a look at our equation. I know that my a value is going to tell me whether this opens up or opens down. So we say, okay, the a value is positive, so that tells me that opens up. So it's like smiley face shape, right? Let's do our discriminant. We're going to take b squared, b is negative 2, minus 4 times a is 5, times c, c is 4. Work all that out, we get negative 76. So negative number means it has no zeros. So what does that look like? Well, let's draw our axis here. There we go. Now I notice it opens up, it does not touch the x-axis. That means it's going to be something like that. I don't know exactly where it's going to be. I don't know exactly how far up it's going to be, but I know it's going to be kind of like that. So we're going to say therefore lies above the x-axis. It has to. If it opens up and it has no zeros, it's got to be above the x-axis. Okay, so the discriminant gives us a nice easy way to check if problems are solvable, right? Check if they're solvable. If we're dealing with an equation that happens to be quadratic and we're trying to solve that equation, and we do the discriminant and we find we get a negative number, that means we actually can't solve that equation. There's no solution to that equation. So the discriminant is going to help us. We could figure out if there's a solution before we even try and do it. Yeah, in the previous lesson, I gave you all quadratics that were solvable because we could factor them and we could find solutions to them. They were all factorable. They all had two solutions. In this lesson, we're realizing that it's more complex than that. So we're going to rearrange the quadratic equation so that it equals 0, just like we did in the previous lesson. Then we're going to do the discriminant to see how many solutions there are. Let's give that a try. So, two different situations here. Here's our first one. Now this is just an example of equation solving, right? So we got a bunch of stuff going on here. Let's solve for x. That means we got to get it all over into one side and have it equal to 0. So here we go. Let's subtract 3x from here and subtract 2 from here to get rid of these so we have 0 on that side. Of course, we've got to do the same thing to the other side because they're equal. So we end up with 2x squared minus 5x minus 3x minus 2 equals 0. Let's collect our like terms. We end up with 2x squared minus 8x minus 2 equals 0. Okay, we're ready to do our discriminant. How do we do our discriminant? We say discriminant is equal to b squared, so negative 8 squared, minus 4 times a times c. There's our a, there's our b, there's our c. What does that work out to? That works out to 32. So that means it's a positive number. We're going to have two solutions. So therefore, we'll have two solutions. Okay. In our next one, I'm going to give a hint and then I want you to try it yourself. We could multiply through the brackets and then move everything over to the left side and have it equal to 0, do our discriminant. Pause the video, give it a try right now. Okay, you're back. Welcome back. Let's try this out. 4x times x is 4x squared. 4x times 2 is 8x. Let's move the stuff on the right over to the left, so we end up with 4x squared plus 8x minus 3x plus 10 equals 0. Let's collect our like terms. 4x squared plus 5x plus 10 equals 0. Okay, we've got our a is 4, our b is 5, our c is 10. Let's do our discriminant. It's going to be 5 squared, b squared minus 4 times a times c. What does that work out to? Minus 135. That's a negative number, so therefore it's not solvable. So if you were trying to solve this, if you were trying to factor this out and do, okay, I'm going to factor it out, I'm going to find two numbers that equal 4 times 10 and add to 5, you can't do it. There's no solution. You actually can't do it. You can't factor this, you can't solve it. There's no value for x that's going to make this true. Okay, let's put this in perspective of a thing that's a little more of a real-world scenario, so we're not just dealing with numbers and unknowns here. The height of a trampoline jumper, so someone jumping on a trampoline, h, that's their height, in meters, can be modeled by negative 6.1 t squared, excuse me, plus 9.17 t, plus 1.997, where t is the time in seconds. How many zeros does this relation have? Y. And how many times will the jumper pass through a height of 6 meters? 6 meters, that's pretty high. That's really high, actually. It's like frighteningly high. Okay, so let's try it out. I'm going to say that this is my A value, this is my B value, that's my C value, because I have a feeling I'm going to be doing my discriminant. Let's get to it. How many zeros does it have? Let's do our discriminant. Our discriminant says we take our B, that's 9.17, and we square it. Minus 4 times A is negative 6.1, times C is 1.997. Let's work all that out. I'm going to get 132.8157. That's a positive number. So therefore, since it's a positive number, it says 2 zeros. Now, question is, why? Why does it have 2 zeros? Well, we're jumping on a trampoline. Our height is going up, and then our height is going back down, and then our height is going back up, and then our height is going back down. We're really in this quadratic just dealing with one journey up and down. That's what we're modeling mathematically. So we have 2 zeros because we have 1, when jumping up. So when we jump right at the beginning, and 1 when we land. So we're at a 0 right when we start, and then we go up, and then we come back down, and when we land again, that's our other 0. And some time has passed in between those. So that's why we have 2 zeros, because we go up and back down. We start at the bottom, we go up, and then we land at the bottom again. Okay, how about B? How many times will the jumper pass through a height of 6 meters? Okay, good question. So that means we got a quadratic that looks kind of like this, right? This is our time, and this is our height. So they're not jumping sideways. Our time is progressing. So remember, this is time on the x-axis. So height is 6 meters. So let's say we have a height of 6 meters. Maybe it's right here. We'd hit it going up, and we'd hit it going back down. But what if 6 meters is not there, right? What if 6 meters is actually up here? Well, we'd never actually get to 6 meters. So we can actually tell if 6 meters is a solution. And here's how we're going to do it. We're going to take our equation, and instead of height, we're going to put in a 6 for 6 meters. Okay, we're going to put in a 6 for our height, and then we're going to solve for t. That's going to tell us the time when we hit 6 meters. If we find that we were to get 2 solutions to this, then we would say, okay, they hit 6 meters going up and coming back down. Now 6 meters is really high, so I hope they're not hitting 6 meters, but we're going to see. Okay, so we still got 6.1 t squared plus 9.17 t plus 1.997. Now before we could solve this, we need to set it equal to 0, right? So we need to get rid of the 6, so we need to subtract 6 from both sides. So we're going to end up with 0 here. The t squared term isn't going to change. The t term isn't going to change. This one is, though, right? We're going to end up with 1.997 minus 6. We're going to end up with 4.003. Okay, so we set it equal to 0. We're ready to go. Here's our A, here's our B, here's our C. Let's do our discriminant. Discriminant is b squared, 9.17 squared, minus 4 times A, that's negative 6.1, times C, that's negative 4.003. What do we get? We get a negative answer. It's negative 13.58. So a negative discriminant means that there are no solutions. There is no time where we end up with a height of 6. So basically what this means is there's no value of t that we can sub into our equation where we end up with a 6 when we put in that value. You can try it out. Go ahead and try and pick any number for time. Try 2 seconds, 3 seconds, 4 seconds, 5 seconds. Try decimal numbers. Try any number you want. You cannot find a number for time that will give us a height of 6. That's because this equation doesn't get there. So we'll say, therefore, we'll never reach a height of 6 meters. We're never going to make it there. Let's go to Desmos and just like try this out graphically really quick. So here's Desmos. I'm going to actually use h for height, and Desmos is going to be fine with that because Desmos can handle using different variables, no problem. 6.1, and I'm going to say t squared, and I'll go plus 9.17 t plus 1.997. Okay, so this is our quadratic here. You notice it looks like we get above 5 meters but we don't quite get to 6. Looks like our vertex, the highest, our optimum value is 5.443. That's as high as we get when we're jumping on this trampoline. And here's another way we could check. We could put in a height equals 6 as a line and just see if it'll show up for us on our equation. And I have a feeling it'll be too high. This doesn't want to graph it. What if I just change that to a y? There we go. So I'll notice I put in y equals, it says 5.8. Let's put it back to 6. You'll notice it's too high. There's no intercepts with our equation. What about, though, a height of 4? Well, there's actually 2 spots we get to 4 meters. We get to 4 meters in the air at 0.265 seconds, and we come back down and get back to 4 meters in the air on the way down at 1.238 seconds. So we can see how finding the intersection between a quadratic and a straight line could give us some pretty important information. And on our work over here, if we were to sub in a value of 4 instead of a value of 6, we would actually get a discriminant that was positive, meaning we had 2 solutions. We could put in that value of 4, move it over to the other side to set everything equal to 0, and we could try and factor it to solve. Okay, now we've got some stuff to practice. We're going to work on those discriminants and using them in equations to figure out how many roots, solutions, x-intercepts, zeros, those all mean the same thing, how many of those we've got. Go for it. Let's try it out.